Good afternoon, class. We are looking at chapter 3 derivatives, 3.5 the chain rule. The second part of the chain rule is implicit differentiation. So we have covered derivatives of and rates, the derivative as a function, basic differentiations, the product and quotient rule, and now the chain rule, which we will continue with all of those formulas that we have seen, the definition, basic formulas, product rule, quotient rule, composite function resulting in the chain rule, exponential functions. In all cases, the derivative is itself. In this case, you multiply by g prime. If the base is b, you also multiply by ln b, the natural log of the base. So, section 3.5, the chain rule, part 2, implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. For example, y equals x squared minus 2x plus 1, or in general, y equals f of x. Some functions are defined implicitly by a relation between x and y. Examples, x squared plus y squared equals 25, x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x and then solving the resulting equation for y prime or dy dx. So basically, you either have an explicit format you are familiar with or you don't, in which case in x and y are intertwined. You, in some cases, can solve for y. In some cases, it's difficult or impossible. So we use implicit differentiation. Here's the simplest example to get us started. 4x plus 2y equals 10. And we are going to do it explicitly first, meaning we are going to solve for y. To solve for y, first we move the 4x. We make a negative 4x on the right side. Then we divide everything by the coefficient of y, which is 2. And as you can clearly see, the derivative y prime or dy dx is simply negative 2. The second method is the implicit differentiation, in which case we are not solving for y and reminding everybody that the derivative of y, d dx of y with respect to x is y prime or dy dx. So 4x gives us 4. 2y, according to this, you can write 2y prime or 2 dy dx. And on purpose, I want to write dy dx. You'll see in a moment why. You move the 4, becomes negative. You divide by 2, and dy dx becomes negative 2. Either dy dx or y prime, they're both the same thing. This tells you what is the independent variable, which is more precise in essence. The difference is that this is sometimes easier to use. So either way, we come up with the same answer. Here's another example. Given the circle x squared plus y squared equals 25, and I remind you that this is the circle centered at 0, 0. Remember, x squared plus y squared equals r squared. We've discussed that already. We want to find y prime. This is simple enough. You can solve for y, but I leave it for you to do so. We are going to differentiate both sides with respect to x implicitly. X squared gives us 2x, but what about y squared? I'm going to remind you that the extended power rule says the derivative of g of x to the power of n is n g of x to the power of n minus 1 g prime of x. So g of x is like y. So what is the derivative of y to the power of n? N y to the power of n minus 1 y prime. So this gives you 2x. This gives you 2y y prime. 25 is the number, gives you 0. Again, this is really the same as this one. Move the 2x, make it negative on the right. Divide by 2y, and y prime is negative x over y, and you're done. Find an equation of a tangent to the circle at the point 3, 4. Well, as you recall, to find an equation of a tangent line, you need two things. You need a pair, which is given. You also need the slope, which we have already found, y prime. All we have to do, plug in, with x being 3, y being 4. And when you plug in, it becomes the slope of a tangent line. Using the point slope, y minus y1 equals m times x minus x of 1. We get y minus 4 equals negative 3/4 x minus 3. We distribute. We get negative 3/4 x plus 9/4. Remove the negative and make it positive 4. Positive 4 or 16 over 4 with 9 over 4 is 25 over 4. So the equation of a tangent line y equals negative 3/4 x plus 25 over 4. If you plug in the pair when it works, it means that we haven't made a mistake here. It doesn't say anything about the process of finding this slope. Find the y dx or y prime, where x cubed plus y cubed equals 6x times y. We differentiate term by term. The first one gives us 3x squared. Y cubed, the extended power rule on y, because y in this case is a function of x. So n y to the power of n minus 1 y prime, that means 3y squared dy dx of y prime. The right side is a product of 6x and y, so I put a raised dot, and I'm going to call him fg. The product rule is used, which means f prime g plus g prime f. 6x gives us 6 times y, and y gives you y prime or dy dx times 6x. And this is the only calculus step. This is the only calculus step, everybody. One and only one calculus step. Of course, we are solving for dy dx, which means we are moving everything involving dy dx to the same side and everything else to the opposite side. So to do so, we are moving this one to the right and this one to the left. And each one takes a negative sign. Remember, we are solving for dy dx. So on the left side, we notice we can factor the 3 out times y squared minus 2x. The right side, also we can factor the 3 out. We get 2y minus x squared. You can drop the 3 from both sides if you want, or you can say I'm going to divide by. So all you have to do, divide both sides by this. In other words, make y squared minus 2x the denominator of the right side. So dy dx becomes 2y minus x squared over y squared minus 2x. Pretty straightforward, everybody. We want to differentiate 4x squared y plus 2y squared equals 18, or we want to find dy dx of y prime. It means the same thing. Notice the first piece is the product of 4x squared and y. We put a raised dot in between, and we call this f times g, and we use the product rule f prime g plus g prime f, which means f prime is 8x times g, which is y, plus g prime, which is y prime or dy dx, times f, which is 4x squared. And right here, what we are looking at, everybody, is f prime g plus g prime f. So this is the derivative of this part. What is left is 2y squared, which gives you 2 times 2, 4y, y prime, and of course 18. Any number results in 0. Done with calculus. We are going to solve for y prime. To do so, we are going to combine these two by factoring the y prime out. We notice we can even take out the 4, so it becomes 4y prime times x squared plus y. 8xy goes to the right, becomes negative 8xy. Basically, put 4 times x squared plus y as the denominator of the right side. You are dividing both sides by that. 4 goes away. Negative 8 changes to negative 2. The final answer becomes y prime equals negative 2xy over x squared plus y. Part B, for x squared plus 6y plus y squared equals e. We are going to do it term by term. Obviously, 4x squared gives you 8x. 6y gives you 6y prime. Y squared is 2y, y prime. Any number including e results in 0. Please understand the right side is a number. Doesn't matter, e, pi, or any other number. Again, to solve for y prime, we put these two together and we move 8x. 8x moves and becomes negative on the right side, negative 8x. These two, we can take the common factor of 2y prime out. So this gives us 3, this gives us y. Remember, the right side, 8x is negative 8x. We can divide both sides by 2 times 3 plus 1. Which means negative 8 cancels out the 2 and changes to negative 4. The final answer is y prime equals negative 4x over 3 plus y. Notice the first term. So we have x. Want to find dy dx. X times e to the power of y plus 2y cubed equals 3x. And this is the product of x and e to the power of y. So we put a raised dot in between and we call it f times g, which means we are going to use the product rule. So first f prime is 1. times g, which is e to the power of y, and now g prime. Remember, the derivative of exponential function is always itself. If it's e to the power of kx, is itself times k. If it's e to the power of g of x, itself times g prime. So the derivative of e to the power of y itself times y prime, because y is like g of x. So itself times y prime, and then times f, which is x. This is g prime f. This whole thing is the derivative of this piece. And now 2y cubed. We follow this format, the extended power rule, 2 times 3, 6. Y squared y prime. We are following that. And of course, 3x gives us 3. Done with calculus. We are going to finish the job by taking our algebraic steps as follows. First of all, this is e to the power of y, moves to the right, becomes negative e to the power of y. Secondly, this 2, we take the y prime out. When we take the y prime out, this gives us e to the power of y times x. We put the x first, and this gives us 6y squared. So one more time, this one moves, becomes negative. This one, you take the y prime out and you write whatever is left. Now, whatever is left becomes the denominator of the right side. Therefore, y prime is 3 minus e to the power of y over x, e to the power of y plus 6y squared, the coefficient of y prime. That's the case, everybody. So it's pretty straightforward, everybody. Find an equation of a tangent line to x squared y squared equals 1 at negative 1 comma 1. So what's happening is that in order to find the equation of a tangent line, we need two things. We need a pair. We need the slope. To find the slope, you have to differentiate. To differentiate, we notice is the product of x squared and y squared. We put a raised dot in between, which means this is f times g using the product rule. So we need f prime g plus g prime f. F prime is 2x times y squared. G plus g prime, again, following the extended power rule, 2y prime times f, which is x squared. The right side is 0, everybody, because it's a number. Now, you can plug in and find y prime numerically, becomes this slope. But it's really a good practice to solve for y prime, which means 2xy squared. This is going to move to the right, becomes negative. And now we are going to divide by 2yx squared both sides. The 2's cancel out. The x goes away with the exponent. The y goes away with the exponent. We get minus y over x. And the slope is the same thing when you plug in the pair. And the notation is minus y over x, such that we plug in negative 1, 1. So you replace the x with negative 1 and the y with positive 1, you get minus 1 over minus 1, which makes it positive 1. Point slope, y minus y1 equals m times x minus x of 1, which means y minus 1 equals 1, x minus minus, that means x plus 1. We get x plus 1. We move the negative 1. And the final answer is y equals x plus 2.